Okay, now we have the recording on. So let's see about collision testing for our Frogger game. Now I'm going to share my screen. You should be able to see it now. So here we have the thing what we did last week. So we made this keyboard control to the green rectangle, and then we had these balls which were bouncing here from the sides. So now let's make it so that we have a rectangle here on the screen, on the center of the screen. And then let's make it so that we can detect when we collide with this green rectangle on this static rectangle. I will not do the collision test with these circles now. I will only show how to do it with the rectangle, because with these circles it would be a little bit more complex because it's a round shape. So, well, not so much complex. We would need to check for all these corners. Well, we can do that as well later on, maybe. But let's first do with the rectangle thing. And here is the code for this one. Let me take this like this so that it's visible. So what we have is that we have two classes. We have here the class ball, and then we have the class of the player, like so. So the player is now this green rectangle, and then we have the ball, which is ball class is representing all of these bouncing balls. Then here we have some initialization. We are creating the player. We are creating an array where we store the balls. Then we are creating the balls here in a for loop. So we have five pieces of these balls. And then we have the function update screen, which we are repeating with this request animation frame. So basically we have a loop which is calling this update screen over and over and over again. And every time when we do that, we call these update methods of these balls and then this player. And with these balls, when we call the update method, we have defined a certain amount of change for the ball coordinates. So on every update, we change the coordinate with the amount of the speed in two axes, in x and y axis. So we have a loop which is calling this update method for every ball. And the loop is constructed by first calling here update screen, and then inside the update screen we have a second request to call update screen with the request animation frame. So in essence, this is our game loop. And then we have set here event listener for the whole window, so that when we click the keyboard, then we can do something. And what we are doing is that we are calling player move left, move up, move right, and move down. And then here are our functions or methods, how they are called when they are pieces of these or parts of these objects. So every time when we call move up, we will change the y coordinate of the player with this much. This has been initialized to be the same size as the width of the player. So the width of the player is 48, and then will be, sorry, where it was. Okay, so the width of the player is 50. It has been decided here. So we are moving the by 48 pixels. Like so. Okay, what I will do now is that I will create create a copy of this file. So there will be a next version of this one. So that player policy test. So here, player collision test is now what I'm going to be showing. And here you can probably see that there is some amount of duplication between this this player and ball, because both of these player and ball classes, they have the same kind of parameters. So they have the starting x and y, then they have the speed change x and y, and then they have these common methods update and draw, even though the update and draw is a little bit different for both of these. So what we could do is that we could also create a base class which these could then inherit, so that at least they would have some common properties. Maybe we will do that as well at some point. But before doing that, let's focus on now on the collision test. And what I'm now going to do is that I'm going to create now this rectangle here to the screen. So let's do it like this, that this is now class rectangle, and then it will also have x and y coordinates, like so. Constructor. No, yes, I'm writing incorrect syntax. Not like this. So class with rectangle with x and y in the constructor function, and then this one will also have update, and this one will also have draw. So now this draw will do it so that it will be basically the same kind of what we have here. Same size, let's make it a bit bigger, for example, 200 wide. Then let's make it so that it's red. Okay, the update we don't have yet, but here we will do collision check. Does this collide with player? And then what we will have here, const rectangle new. Then let's put it somewhere, for example, 100, 100. And then we must call the update and draw for that one as well. So for example, here, like so. Now we can see that, okay, we have this kind of rectangle variable here, and then we have this player thing. And now we can see that, okay, we are starting to have quite a lot of these duplicate or repeating update and draw calls. We have here update, draw, we have here update, draw, here, here, and here, and here. So this would be a clear indication to us that, okay, now we can probably make our code a little bit smarter, so that it's not like this that we have to keep track of these variables here and then call these methods for all these objects. Here we already have this kind of array for this ball storage. We are creating these new balls and then we are calling update and draw. But there is no need why we should just limit this to ball storage. So what we could do here is that we could rename this one. So what we're going to do is that we are going to rename it to be game object storage. Like this. And then what we'll do is that game object storage push player game object storage push rectangle. And here we are creating the balls. Now when we have done this, we can dispense these calls for this rectangle player update and draws, right? Because now all of our game objects are in this array, and all of them have the same kind of update and same kind of draw methods. So we could call these methods for all of those objects in this array. So now we have made this update screen a little bit more simpler. And okay, so now we should have this rectangle on our screen. Let's see how it looks like. No, we have it. Forget something. Rectangle 100 and 100. Oh yeah, I'm still looking at the wrong file. Okay, now I have the correct one. So now the idea would be so that we can detect when this red rectangle, when it hits our player. So now you can see it is not hitting. Now it should be hitting. Now it should be hitting. Now it's not hitting. This is hit. This is hit. And this is also a hit. This is hit, but this is not a hit. Okay. Let's make it so that we'll print to the console whenever there is a hit. Oops, I have now some update screen close. So I will make it so that we will print to the console every time when there is a hit check done. There is too much scrolling. Like so. And as I said, the hit check should be done inside this object. So each object should be doing their own hit checks, especially now when we want to check that do they hit the player. Okay, and now we are going to do it in the update method of this rectangle. So our rectangle is here. So now we will check that if this x is larger or equal to the player x, let's start from this. And I'm going to also delete these up and down things so that they don't pollute our console printouts. Okay. Now now there is a hit. Now there is not a hit. You can see what we are checking is the x and y coordinates only. Now there is a hit, as you can see. So we are checking that is the where is our rectangle? Here. So we are checking that is the x coordinate of the rectangle, is it bigger or equal than the player x? And if so, then there is a hit. So basically we are checking that is the player x smaller or equal than the x coordinate of the rectangle. So now it is. Now it's not, as you can see. You can see it from here that this is now growing. Of course, this is not what we want to do. It would be opposite ways, right? That we should know that now it should be detecting a hit, and not now. So this is vice versa. So now it is detecting a hit. I'm going to delete these balls here as well. We don't need these. We are just making this uglier. Okay, so now we can see that it is detecting hit, and this is only considering the x-axis. When we move to the left side of this rectangle, like so, now it stops detecting a hit. As you can see, the x and y on the rectangles are the top left and on the top left. So that's why when the green rectangle is now at these coordinates, as you can see, it's a little bit to the left. There is not a hit detected. Now there is a hit detected on the x-axis. We are only considering x-axis. Now we should, when we move now the hit detection should notice that, okay, now we are not hitting it anymore. So how could we, what kind of check would we need to do that we could check that now we have a hit and now we don't have a hit? Now the hit detection is only working on this left edge, as you can see. And only when thinking about this top left of our green rectangle. So we would need to also add the width of this red rectangle to our check. So let's do it so that we think here that if like this, and then this x plus this width is still smaller than layer x. Okay. Now we don't have the width here specified, so we should do it. Okay. Now I have a syntax somewhere. That's the problem. I have too many brackets. Too few. And here will also this width, this height. So let's create these values as parameters. So here it's like so. Okay. Now it's not detecting a hit. So we made a little bit error. Now you can see now it's detecting a hit. Now it's not detecting anymore. So this should be like you can see now. Now we can detect on the x-axis that when the top left, so the player x and y is this one here. So that's the x and y. It's the same thing for this rectangle. This corner here is the, oops, this is a bad. So this top left corner here is the x and y. So now by adding the width to the x, we are getting the coordinate which is here. So that's the x plus the x plus width. So that's the reason why we need to do that. So we are checking now the value of this coordinate and this coordinate against the coordinate of the player x and y. And that's the reason why you can see here, when we are at this location, it's not detecting a hit. When we go here, now it is detecting a hit. So we are checking the x and y of the player. When does it hit? When is it between the x and y, or between the x and x plus width of the rectangle? So that's what we are checking here. Now there is not a hit, and now there is not a hit because the x coordinate of the player is outside of the x and x plus width of this red rectangle. Now when we move it here, now it is inside, and as you can see, it is detecting a hit. Now it's inside, now it's inside. It is still inside because we are only checking the x and x coordinate of the player, but now it is outside. So, and this logic does not change even if this red rectangle would be moving, because it always has a certain coordinates, so the movement does not affect this check at all. With the movement, we are only modifying the x and y, but it always has some values what you can check. Okay. So next step would be to make it so that we would be checking also, taking account also the width of the player. So we need to think about this. So that would be x plus the width again. Now it gets a bit more complicated because we can have the situation where we have the red rectangle is like this, and then we can have our player rectangle like this. This would still be a hit. This should be a hit, and of course this should be a hit as well. So now we must check this and this and this, and then we must check this and this and this, right? So we have a check that like this, and then we are going to checking this player X against these points. That is this inside this area, and then we are going to be checking another check that is this part inside this and this. So we'll have another check. Right? Then we can know that is any part of our player in the x-axis, is it inside this red triangle? So we could have here a second one. If is x smaller or equal than player x plus player width, right? Because we are going to be checking about this point here. And this dot x plus this dot width is this one smaller or greater or equal than player x plus player width. So this code line, oops. So this check here is now doing this part. So we are checking that is our right side of the player object, is it inside of these? This one does this check here, what we have here, and then this check is being done this purpose. So as we can see, this is exactly the same as this one. Only difference is that what we have here and here. So instead of player X, we have player width here and here. And then we have this bracket. So what we have, in fact, is that This bracket this would be there. Oh, sorry. Then we have here and here. Yeah, so I like to use these brackets so that it's clear that, okay, first we calculate this one, and then we do this operation. And then we calculate this, then we calculate this, then we do this operation. And then after that, this, and this will be checked with this AND operator. Now I think I have too many of these brackets. Hit here, hit 2, so we can see the difference. Okay, so now this is saying hit because hit is coming from only from the player x coordinate. This one it's not taking player x plus player width. And now we have something which is not correct. There is a problem. What's the problem? I think we don't have a player width at all. Yeah, that's one of the problems. Uh-huh. Okay, now it's still checking the X layer. Now we are getting both checks. Now it's both of these are checking. Now it's only getting a hit for the player X plus player width. Now there is no hit. So now we have done the hit check for the X-axis. We can detect now there is not a hit. This is a hit. This is hit. This is hit. This is hit. And this is also a hit, but this is not a hit. And we are only working on the X-axis, as you can see when I have here. We have here now still this hit. Next step is to do it also on the Y-axis. That again, this should be hit, and this should be hit, but this is not a hit. So we can do it on the Y-axis as well. So rectangle, and then well, basically these are. So exactly the same logic applies there. So let's convert this hit X and then hit Y, hit Y. Now, okay, let's read it. Oh, what's the problem? Why don't I get anything now? Yeah, so now it's saying hit X. Is the console log window where I'm getting that? No. So now it's hit Y, also hit X, like so. So now we have both of these conditions valid. Now we should combine them because now it's only a hit. Now it is not a hit. Now only hit. Now only hit. Now we don't have a hit, but now we do have a hit. Now we have a hit. Now we don't have a hit. So we should actually have those combined the logic. And let's see how to do that. Maybe it should be so that we should have it's even more complicated with these brackets. So and let's see. Now we have combined this check that it should be only in this situation. Unexpected token. We have too many brackets here. Yeah. Oops. Here is the correct amount of these brackets. So let's see. No. No, there's still a bit problem. Let's see what. Okay, now it's taking only the X. Okay, did I take the wrong pieces? So no, so this should be OR. Okay, so now it's like that. And then now we must combine the Y thing there. This is the one what I was thinking about. I think here we should have this and it's making totally now. Now there is not a hit. Now there is Okay, maybe I will need to clean this up a little bit to a better looking solution. Having this many and or combinations gets difficult to read. It's too difficult to read, but that's the general logic anyway. So what we would need to do is to combine these. I think it's maybe better to create separate situation variables about these, and then do a separate check here. It gets too messy if I combine all these into a single statement. But that's in any way the main logic. The another thing what I wanted to talk about is that now we have these classes here, which have quite a lot of in common. So they have these start X and start Y, and then they have this movement speed. Then we have the width and height, which is also for all of these. And then they have the update and draw. So what could be done is that we create a single game object class, something like this. Like this, and then we take all what is common to these objects. So we would take here start X, start Y, and we could put if we play with rectangles only like we play in this game, so width and height, and then we could set speed X and speed Y. So these are things that are common to all of our objects in the game. So then we would need to write this code only at one location. So here we do this once, and then the basis what we could do is to take the movement, the basic movement, that if there is this speed X or speed Y, then this would be the basic movement logic. So we put that one here to the update, and then draw is something that we don't know what to do, so we could print here simply that, okay, console log. Implement. Okay, so now when we want to use this to our advantage, that's that we have classes which have these things in common. So we will inherit from this one. So our player class would have extends game object. So now we can delete this constructor from here altogether, since there is no special properties what this player would need. Player has move up and down. These are special things. Now what I'm going to do is that this movement speed Y, so this would be simply speed Y. So we'll use the same names from these. Then update, okay, there is no implementation for the player update. Here is implementation for the draw. Draw for the player, and these are now coming from the game object. These width and X and Y, like are these speed X and speed Y. So there is no need for the game object to have a similar kind of constructor what the player object to have a similar kind of constructor what the game object has. So we can make a little bit more general, and then this rectangle as well. would also extend game object. So now rectangle also inherits the properties of the game object. So we don't have to have this one here copying everything. Now the rectangle has this special update function, so we're doing this one here, and then this is also special to this one. And then same thing with our ball as well, what we had previously. So this ball could also be made so that it extends game object. And this with the speed x and speed y and x and y, these are the same thing as what this has. So the special things would be to have this radius and color. And because we need those, we need to then duplicate here now the parameters for this. Like so. And then when this ball should initialize now the constructor of this game object, we should call super and then deliver these parameters there. And now this ball is adding this radius and color to itself. So we are taking these from here. Then we have here update, but this update is now exactly the same what the game object itself has. So there is no speciality in here. And then the draw is a special one. So our class has become a little bit shorter one. So we have now 3 classes which had quite a lot of similar things. So put all those similarities in a common place, we declare this game object class here. So this is the one from which this ball inherits, and then this player inherits, and this rectangle inherits. And then these classes only implement those parts which are special to these. So rectangle has this special collision check thing, and it's drawing itself with this. Then this player thing, okay, it doesn't have any update logic, or actually it needs to do it so that there is no code executed, because the player movement is done with these move down, move left things, and this draw is now again its own implementation, but the x and y and speed and y usage and initialization are the same as this game object. So with this we could simplify these things a little bit. Now we need to just pass these parameters. So this is the x, y, and what were the width, height, and speed, and x and y axis. So this is now width and height, and then speed, which was now initialized to be 50 and 50. And then for this rectangle, x, y, width, height, and speed, we don't have any speed for this, so it's 0, 0. And then we could have for the balls if we would still need them. So that could also work. 35,000 outputs already. Somehow gets very slow when there is this much console outputs. I cannot access game object before initialization. There is some problem. Okay, yeah, there is now problem in which they are introduced. So it's with the ball. So I have this ball introduced before the game object. So order needs to be in opposite way. So like this. So game object is our base class. And now ball is extending this game object. Because it's extending it, we are calling this super, which triggers a calling of the constructor in the game object. That's the reason why we need to accept all these parameters for this ball, because we are immediately delivering them to the constructor of our parent, which is this one. Let's try again. No, nothing is visible. Why is that? Some problem is still there. Is the canvas visible? Yes. Okay, okay. Game object storage. What is the problem now? Why not be visible? Let's see a bit breakpoint. So there we are creating a new player. Class directed game object. Update here. Okay, that was the ball with the update. Just the rectangle. So let's see how these initialized. Okay, this X is undefined. Okay, so this would now. Okay, I have the incorrect variables. What are they? So these are start X. So here is the mistake. So this would be just X and Y, not this. Okay, so now they are back visible. Okay, but yeah, so with this kind of class inheritance, you could have a more simpler class structure, especially if you start to get lots of duplicate things. And now in our game, where we have the this Frogger game here. So now we think about what objects are similar. So these cars are all similar kinds of objects. And then these logs and turtles are all similar kinds in that way that all of these are moving left and right. Only special thing is that when car hits a turtle, the turtle dies, but when turtle hits a log, it gets carried with it. So that's the difference. So there is quite a lot of commonality. So you could have this kind of common game object which has quite a lot of common properties. And one more thing what we could see is that how to draw images. Especially since there was this talk about these sprites in the instructions. So let's get this kind of sprite sheet for the Frogger game. So I'm going to take, let's see, this. So here we have. I have a nice sprite sheet. So a sprite sheet is an image which contains now the graphics for the game in a single image. So let's see how we can use this. Where is here? Here. Okay, so let's see how to then draw an image to the screen. So the idea for us would be so that all our game, at least in this case, when you are using this kind of sprite sheet. So the idea would be so that these are now our game graphics. So, and all the graphics are coming from the same image. So for the frog, when we have not animated it at all, we would show this here. Then for the logs, we could show these parts. Here we have Interesting that these are split, so maybe I would edit this a little bit. But in any case, let's see how we could use this frog, for example. Or then we have the cars, which are here also. So first thing what we must do is to load the image. Yeah, I will create again a new file from this. Then after the class, I will give you a bit more cleaner collision test example. It's not so straightforward. It takes a while to get this correct, so I'm not going to do it now here. So what I'm going to do here is that I will read it in here. So, so like this. Okay, so when we want to use an image in with Canvas, so we have here. So how it works basically, it's like this, that this is what we already saw with, I don't remember whose code it was, but somebody had already images working in some way. They were using separate images, but in very basic, it's like this, a call to the draw image, and then we point to what image and then what coordinates, X and Y. So this is where to draw it, but here it's not very much. So then, so here are the different versions of the draw image. So this is the one, so draws an image to the X and Y coordinates. Then there is the possibility of specifying the image width and height. So you could scale an image if you would like. And then there is the possibility of slicing an image. So then here we have quite a bunch of these parameters: sx, sy, s-width, s-height, dx, dy, d-width, d-height. So what happens here is that we have this source image, which is now the S, and then we have the destination on the canvas, which is now the D. So dx and dy means at where on the canvas and at which width. So with this functionality, we can take a source image and then select a certain piece of it, for example, this piece to be drawn from it. We can give the coordinates that take the x coordinate of, what is the x coordinate here? Can I see it now? This used to show the coordinates for the point there. Rulers. Okay, well, we will give it a try with some experimentation. But in any case, the idea is so that we will give some coordinates that, okay, now draw an image from these coordinates starting from here with this width and this height. And that's what you can do with this slicing. But first we need to load the image. And for that, there is a mechanism. So I'm gonna do it here. We will start the drawing of the screen only once we have loaded the image itself. So the image loading is done asynchronously and it can take a while. So that's the reason why we'll do it with an event handler. So yes, here I will create Rogger sheet equals now a new image. And then I will create an event handler for this. So Rogger sheet, and then on load, Then what to do when this has loaded? Well, we will, okay, let's do it like this. Let's first print out image loaded. And then when we put here an src attribute, like so, and now we deliver the image address. And how we get the image address, I think it was here. So creating an image from scratch. So we point the source path to it. So now it should be the same path in this folder. So Frogger sheet png like this. So now if this works, when the image has been loaded, we should get this print out to the console. So that is the first part, the loading of the image. After we have loaded, then we can start using it and then draw it to the canvas. But first we must load it. So there it says image loaded. Okay. So now the next step will be to do so that we start our game once the image has loaded. So now, for example, for the player, what we will do is that our player object is here. Now here we have been drawing this green rectangle. So instead of this green rectangle, we will now draw our image. Let's first draw it using the basic drawing mechanism, this one. So these will be incorrect. Incorrect commenting. So context and then draw image. Same way what we have here. Then we give the image, which is now this Frogger sheet, which we have now here as a global variable. So Frogger sheet, and then this X and this Y. Let's see. We should now have the whole image here drawn. Yeah, so now we can move this image like so. But this is not what we want. What we want is to have only a small piece of this shown. And now we would need to get the coordinates, but I'm so bad with the Photoshop that I cannot get the ruler thing now out. So I will have to experiment with these coordinates. So what I want is that I want to draw only this small piece here. So we can experiment first with this scaling, just so that you can see. So this is now the image on its natural size. So then we can give width and height. So if we put here, for example, width 500 and then height, for example, 100. Let's see how it looks like. Now it's 500 width and 100 height. So it looks kind of bad. So it is scaled those values. But that's not what we want. We want to do the slicing. So we have the image, source X and Y. And now the source X and Y is pixel 1 and 1. So here on the top left of this first frame here. So 1 and 1. Then next comes the width and height of the source image, what we want to draw. Yeah, needs to be a ruler here somewhere. Here. Okay, so it is about 15 pixels wide. This one has, this image is using 15 pixels only, so this is a very small one. So what we could do also is to resize it to a bigger one. But so 15 and 15, and then so that was the height and width, or width and height. Then we come that where we want to draw this and at which size. So now where we want to draw to this x and this y, and then this, well, let's try this width and this height. Now we're going to be scaling it up a little bit. Let's see how it looks like. No, it's nowhere to be seen. Incorrect values there. Somebody's grunting there on the microphone. So let's see. SX. Oh yeah, I have these incorrect. Okay, now we have here the scaled up image. It looks kind of bad. So my actual size would be better. Maybe the width would be better, 16 and 16. Yeah, it's 16 pixels wide and 16 pixels height, I think this one. Is the height small? Yeah, so with this sheet, it looks like this. Yeah, okay, it's correct. It's 16 and 16. So have it in the natural size. I would have here 16 and 16. Now we have it in its original size, which is very small, only 16 pixels. So what we could do is to make this one bigger. So if we multiply this by, put this, let's say 300% bigger, and save. So now it's maybe more better solution. Yeah, it's bit bigger. So now we have the 16 times 3. Now what is that? What is the 16 times 3? 48 exactly, yeah. Now it's not starting at 1, 1. I think it's starting now. 3. Yeah, so now we have the frog at 48 pixel size with this. And now, if you think about that, if we would implement animation, we don't have time for this, for that one. Then it would mean that we would switch between, for example, for the jump, we would switch between this frame and then this frame and then get back to this one. So that would need then to be starting a timer. So we can, for example, do that. Let's see here. So set interval, and a timer of, let's say, 16. let's make it slower. 200 milliseconds. And okay. You would need to store the coordinates as well. So how should we do it? Well, let's make, for example, this kind of very crude frame counter. So now plus and then if frame counter modulo 2 equals 0, then let's draw this one. And then if else, we draw the second one. So now what will happen is that we will be drawing the second frame. So this frame alternating. So this is something like 48, 51, maybe 52, the starting pixel location. Maybe I would need to measure this exactly, but let's see how it looks like. Yeah, this is something that I just did not have in any way pre-planned. Maybe not so good idea. This kind of demonstration, but let's see, does it work at all? No, it's kind of lots and lots of frame counter. Yeah, this frame. Can you see the frog anywhere? No. Oh yeah, okay. Is it drawing it anyway? No. Okay, yeah, maybe this was a bad idea. I need to prepare a bit more for the animation thing for next class. Yeah, so forget about this. Yeah. Try to show this without any preparations. But in any case, here is an example of how you can draw a slice from an image, load an image, and then some preliminary hit tests. So let's check out a proper collision check next time. Our next class is when is it? Is it Thursday? Yeah, on Thursday we start at 9. Okay, so on Thursday, let's see a better working heat test with all the conditions nicely formatted. I will show you then a way how to do it without having like an exceedingly complicated and or combination thing here. And then we'll also see on how to do this kind of frame animation. And tomorrow we have this tutoring lesson at 2 o'clock. So yeah, so if you want to some help on how to proceed on your exercise, then please come tomorrow. No, sorry, we have today. Today we have it. Yeah, I was living on still Monday. So today is Tuesday. Yeah, so today at 2 o'clock we have this tutoring session. So please come there if you want to have some help on your exercise. Yeah, and I will put this to the GitHub as well. But before that, I will try to make today a little bit cleaner this hit test so that it actually works and is easier to read. If I now try to make direct combination of these, then I think it will look quite messy. Okay, so see you at 2 o'clock on our tutoring session. If not, then otherwise let's continue on Thursday with frame animation from this kind of sprite sheet. All right, so that's it for today. Bye.
Thank you. Bye.